Okay, let's have a look at this. So we said that we don't need to introduce logs if we can get the bases to be the same. And then we can cancel the bases. So let's have a look at this one. So we've looked at before where I might have something like 2 to the power of x is equal to like 8 to the power of something else. And when this is the case, like usually what we've seen so far is that this base here can be written as this base to the power of something else. So like 8 we know can be written as 2 cubed, and then we continue writing the rest of the power. Over here when we look at this one, 32 can't be written as 8 to the power of something else, so we can't do that. So we need to look at what other bases could I possibly use here. So 8 can be written as the example I've just used, as 2 cubed. So I can rewrite this as 2 cubed all to the power of 4x plus 3. And I can also write 32 as base 2 power of 5. All to the power of 1 plus 2x. And once I get to here, it's nice and easy because I can use the rule from page 21 of the log tables that a or some base with some power all to another power means that I have to multiply the powers together. Okay, so this means that I literally can over here say that I have 2, it had a power of 3, so 3 must be multiplying the other power, so the 4x plus 3. And likewise on the other side of the equals, that 2 to the power of 5, that 5 must multiply the other or the other power there. Okay, so once you have the powers fully simplified, then you can cancel those bases that are the same. So here now you can see that they have the same bases and the powers are fully simplified. So we can cancel the bases and just look at the powers together. So 12x plus 9 is equal to 5 plus 10x. Okay, and then once we get there, this is what we're used to now. We can find x by getting all the x's on one side of the equals. So I'm going to subtract 10x from both sides to move all the x's to the left. And likewise, I'm going to move all the numbers to the right. I'm going to just do it in one step here. So I'm going to get rid of the 9 from the left-hand side. So I have to subtract it from the right-hand side as well. So I end up with 2x is equal to minus 4. And I want to get rid of the 2 that's multiplying the x. So I'm going to divide both sides by 2 here. So I end up with x as minus 2. Okay, if you want to verify your answer, so to verify that x is minus 2, just sub it back in. Say, does this work? Does 4 times minus 2 plus 3 as a power on 8, does that equal the same number as 32 to the power of 1 plus 2 times minus 2? Okay, so does 8 to the power of minus 8 plus 3, so minus 5, does that equal to the same thing as 32 to the power of minus 3? Okay, so you just need to check, are those equal to each other to verify your answer.